Okay, so here are some continuity questions. Continuity essentially is broken up into three parts. Number one, does the function value exist? So that's what question one is. Question two is, does the limit exist at that same x value? And does the function value, is it equivalent to the limit at that same value? So we're going to look at -1. We'll look at some ones where the limit exists and some where the limit doesn't exist. And there we go. Excuse me, where it's continuous and it's not continuous at the corresponding values. So -1 is just right here. So does the function value exist? Yes. What is the number? 1. Does the limit value exist? Well, since the function is going towards -1, excuse me, going towards 1 from the left and the right, does it exist? Sure, it's equal to 1. And does number 1 equal number 2, or does the function value correspond with the limit statement? That answer is true. You bet. So therefore, is it continuous? Yeah. So that's the feel-good problem of this section. Let's look at one where it's not continuous. So therefore, f of 2, the function value at 2 is 1, because this is a really tiny hole, and this dot here is the same size as this open hole here. The function value is 1. Does the limit exist as x approaches 2? Well, no, because the left-hand limit is equal to 1, the right-hand limit is equal to 0. So this limit doesn't exist, since the left-hand limit equals 1, which is not the same as 0, which is the right-hand limit. Does the function value equal the limit? No, since the limit does not exist. And finally, number 8 is asking the same question as 7. It's just using the word continuous. Does the function value equal the limit? No, since the limit does not exist. Here's another example. We're looking at as x equals 3. X equals 3 is right here. Does it have a function value? Yep, it's 2. Does it have a limit value? Well, the left-hand limit's going towards 1. The right-hand limit's also going towards 1, so it's 1. Does the function value equal the limit? Nope. No, since f of 3 equals 2, which is not equal to 1, which equals the limit at x equals 3. Therefore, is it continuous? No, since f of 3 is not the same as the limit at x equals 3. Okay. Here we're going to look at is it continuous at x equals -2. -2, you notice, is way over here. Notice that there's only really one side to this function here, so we're only going to consider the right-hand limit, and that's sufficient. If it's not defined on the left-hand side, then you would just consider the limit on the one side where the function is defined, provided that limit exists and is considered continuous at that point. So does -2 exist? Yep, the function value is 2. Does the limit exist as x approaches -2 from the right-hand side? Yep, it's going towards 2. Do these two agree? Sure. 2. Is it continuous? Yes. At what values of x is f of x continuous? Well, it's continuous starting here, starting at this point. All these x values are continuous. Not continuous here because these limit values don't agree. Left and right-hand limits don't agree. However, it is continuous here. Not continuous here because the left and right-hand limits don't agree. It is continuous here, but not at that point because this function value doesn't agree with these limit statement. The limit doesn't exist here at 4 because there's an open circle here. And finally, that should be an open circle that's left over from a previous version. Open circle there, and then lastly, everywhere in between 4 and 5, but not at 5. So how would you write that answer? Well, I like to use interval notation using brackets and parentheses. So bracket -2 to 0, open parentheses, 0 to 2, open parentheses, and then 2 to 3, and 3 to 4, and 4 to 5. Can we make a new function g such that f of x will be continuous at x equals 4? Well, here's x equals 4. 1, 2, 3, 4. Can I fill this point in, or is there a way that I could make it so that this limit it's continuous at this point? Well, if it's continuous, if the limits agree, well, the limits agree at this point. There just happens to be a hole here. So if I fill that in, if you will, so if I let g of 4 equal 1, then it would be continuous because the function value would agree with the limit value, so therefore it works. And one more question, I believe, and this one is false or not possible. Can we make a new function g that is an extension of f? So pretty much you take everything in f, but you just add a little bit defined by g to make it so it's continuous. At this case, we're looking at 0. Well, since I could fill this hole in here, but would that make it continuous? No, because what fails by filling this point in right here? Two things. First, it's no longer a function because it fails the vertical line test. Also, more importantly, in terms of a continuous function, the limit doesn't exist. The left and right hand limits don't agree. So is g possible? No. Since the limit does not exist at x equals 0. And that's it for continuity. Pretty straightforward concept. As long as you understand function values and limits, you're all set.